In this example, we're going to look at this function of three variables, find its domain and range, and then sketch several level surfaces. So let's start with the domain and range. Based on what you've already learned in class, put this on pause and write down what you think the domain and range is for this function. Okay, remember a domain is going to be the set of all input values. So we look at the function and say, are there any values we can't input into here? And we see there aren't any numbers that are going to cause us an issue. So the domain is going to be x, y, and z that are all real numbers. So that's the same thing as R3. Okay, and then range is going to be all the output values of the function. So we look at the function and say, what types of values can we get out? Because we're squaring x and y, we know we're always going to have a positive number, or we could get 0. So my range is going to be from 0 to positive infinity. Okay, now as we try to visualize this function, I want you just to notice, let's just evaluate the function at a couple points. So suppose I evaluate it at 0, 1, 5. If we plug that in, we see that that's going to map to 1. Okay, so another way that we can write this is going to be as an order quadruple of numbers. I'm going to have 0, 1, 5, and then the output, which is 1. Now notice, because there's no z-coordinate in the equation, if I leave x as 0 and y as 1, I can change z to be anything, and it's still going to map to 1. Now as we try to visualize this, notice we can't graph this because we need 4 dimensions. So that's where instead we're going to look at the level surfaces. So the level surface are anywhere where the function is equal to a constant. So I have the function, and c here is any constant. So let's just pick any constant. We could start with 1 since we looked at that before. So let's graph everywhere where the function is mapped to 1. Okay, and we want to do several of these, so I'm going to also pick a couple other that we'll do as well. Okay, so starting with this first level surface, I want you to take a second, based on what you remember from Math 13, put this on pause and try to sketch this surface. Okay, if you correctly identified this, this is an elliptic cylinder. Remember, it's a function of z as well, so that's how we get the cylinder. And so to actually graph it, let's put this in the standard form of an ellipse. So notice multiplying by 9 is the same as dividing by 1/3 squared. And I'm writing it like this so that we can see how to graph the ellipse. First, we're just going to graph it in the 2D xy plane, so we'll just do a trace for a second, and then we'll do the whole thing in 3D. Okay, so under the x, because I have a 1/3, that tells me I'm going to go out in the x direction a distance of 1/3. Because I just have x squared and y squared, I know this ellipse is centered at 0, 0. So I'm going to start at 0, 0 and go out a distance 1/3. And then in the y direction, I'm going to go up a distance 1. And then this is going to be my ellipse. Oops. You get the rough idea? And now we want to sketch the whole surface in 3D. So on a new board, I'm going to sketch the same thing that I had in my plane. And then remember, once I've specified x and y, the function has the same values for all z. So that's how I get this cylinder. And everywhere along this cylinder is where the value of my function is equal to 1. So if we go back to these 2 points that we were looking at in the beginning, notice we can see those visually. They were the point 0, 1, 5 that mapped to 1 and the point 0, 1, 10 that mapped to 1. So on our level surface, 0, 1, 5 is probably roughly around here. And 0, 1, 10 is probably somewhere up here. And both of those map to 1, which is how we're visualizing them on this level surface. Okay, so go back and do it with these other two. I want you to sketch both of these and add them to our 3D drawing on the next page. So put it on pause for a second. For this middle level surface, Once we get this in the form of the standard equation for the ellipse, we see we're going to go out 2/3 in the x direction and 2 in the y direction. So let's add that to our picture over here. And everywhere along this cylinder is where the value of the function is equal to 4. Okay, and finally let's draw the last cylinder. I think you're seeing the pattern. These are all going to be cylinders, elliptic cylinders. So sketch this one on the far right. When we get it in the standard form, we can see we're going to go out on the x-axis 1 and up on the y-axis 3. So if we add that to our picture, we'll get this elliptic cylinder, and everywhere along this elliptic cylinder is where the function has the value 9. So we can visualize this function as we move further and further out on these elliptical cylinders, the value of the function is getting bigger. And just as one last thing to add, let me put the Mathematica version of this drawing just so you can have the visualization in your head. And that's a quick sketch of several of the level surfaces. And that's it.